Will a precipitate form when 125 milliliters of 0.148 molar lead-2 nitrate is added to 68.5 milliliters of 0.0430 molar potassium carbonate? All right, first of all, let's look at what the precipitate would be. And we know that if we take lead-2 nitrate, which is aqueous, and combine it with potassium carbonate, the products of this reaction are going to be potassium nitrate and lead-2 carbonate. Now, how did we know what was aqueous and what was solid? That goes back to our solubility rules that we were introduced to in Chem 1 in Chapter 4. Also, since we're looking for will it precipitate form and we know we're looking at KSPs, we can actually look at the KSP table. And when you look at the KSP table, the only one of these that you find on the KSP table is the lead-2 carbonate. So we would look up the KSP for lead-2 carbonate, and it is 3.30, or just 3.3 times 10 to the minus 14. The KSP table also gives us kind of a net ionic equation for this. It's instead of the ions forming the solid, it shows us that lead-2 carbonate would ionize into the lead ions and the carbonate ions. So based on what we've learned in class, we also know that the KSP is equal to x squared. That's actually not going to be used for this problem, but it is. And we know that the KSP is solved by knowing the concentration of the lead ions times the concentration of the carbonate ions. So in order to decide whether a precipitate will form or not, we have to calculate a Q. And a Q is calculated the same way as the KSP. So to calculate the Q, we need to know what's the concentration of lead-2 and what is the concentration of the carbonate ion in this solution. Well, to calculate the concentration of the lead, where's the lead-2 ion coming from? Lead-2 comes from the 125 mils of 0.148 molar. That's where the lead's coming from. What's the total volume of the solution? The total volume of the solution is the 125 mils plus the 68 mils, so 125 milliliters plus 68.5 gives us a total volume of 193.5 milliliters. Okay, so to calculate the concentration of the lead-2, what we want to know is what's the concentration of lead in the 193.5 milliliters when we combine, and I'm going to have to flip back a previous slide to see what the molarity and volume are. When we combine the 0.148 molar and we're going to use 125 milliliters of that. Okay. So we will know that the concentration of the lead in this solution when they're mixed will be 0.0956 molar. Likewise, we need to figure out the concentration of the carbonate. M1V1 equals M2V2. So what is the concentration of the carbonate in the 193.5 milliliters? And where's the carbonate coming from? Well, obviously it's coming from the 68.5 mils of the 0.043 molar. So when we calculate that, the concentration of the carbonate, I get 0.0152 molar. That's the carbonate in the solution. Okay, so now we know when these are mixed what the lead 2 concentration will be and what the carbonate concentration will be. We need to take these concentrations of lead and carbonate and plug it in to solve for Q. As we can see here, the Q is equal to the concentration of the lead times the concentration of the carbonate. So Q is equal to 0.0956 molar times the carbonate, 0.0152 molar. And I get 1.46 times 10 to the minus 3 for Q, for the reaction quotient. Compare the Q to the KSP, and obviously the Q is much larger. 10 to the minus 3 is much larger than 10 to the minus 14. So since the Q is so much larger than the KSP, a precipitate will form. So the answer is yes. Will a precipitate form? Yes.